All right, let's just jump right in. We're going to talk about one of the wildest, most ambitious tech ideas I've heard in a long time. The plan? To build massive data centers, but not here on Earth. Nope. We're talking about building them in the cold, empty vacuum of space.
So get this. This message wasn't from a person. It was the very first thing an AI ever said after being born and trained in orbit. This was a huge moment, a historic first for a little startup called StarCloud.
And that's just the beginning. Their ultimate goal, their grand vision, by 2035, they want to have an orbital data center that's 4 kilometers by 4 kilometers. I mean, that's the size of a small city, and it would have more power capacity than the biggest power plant in the entire United States. It's just a staggering idea.
So you gotta be asking, how on earth did anyone come up with this? It sounds straight out of a sci-fi novel, right? Well, it all started with a founder named Philip Johnston, and an idea that, let's just say, was a bit of a dud at first.
Now, Johnston wasn't your typical rocket scientist. He had a background in math and physics, sure, but it was really inspired by this quote from Sam Altman. The idea is, it's actually easier to build a really complex, ambitious company than a simple one. Why? Because if you're trying to solve a genuinely hard problem, the best people want to work with you, investors get excited, basically all the other hard parts of building a business suddenly get a whole lot easier.
Okay, so here's where it gets really interesting. Johnston's first idea, Lumen Orbit, was to beam solar power from space down to Earth. I mean, it sounds brilliant, right? But there was a huge problem. You'd lose 95% of the energy just getting it here. The economics were a total non-starter. But then came the pivot, the light bulb moment. What if, instead of bringing the power down to the computers, you bring the computers up to the power? Just flip the entire problem on its head. And look at that. Suddenly, the whole thing becomes 10 times more viable, a complete game changer.
Okay, so with this new, actually viable idea, things started moving fast. They put together an absolute dream team. And, get this, in just 15 months, they launched their first satellite, StarCloud 1. They were out to prove they could solve the 3 big, hairy problems of putting computers in space.
And I mean, what a team this was. You had Ezra Fielder, the CTO. This guy is a PhD-level expert in satellite structures and, crucially, deployable radiators. We'll get to why that's so important. Then you got Adi Oltian, the chief engineer, a total rock star who came from Microsoft GPU clusters and was a lead architect on SpaceX's Starlink. So you have the hardware guy and the software and systems guy. That combo? Absolutely lethal. It's why they move so incredibly fast.
All right, first major hurdle, radiation. You see, up in space, you've got all this cosmic radiation flying around. If one of those particles hits a memory chip just right, it can flip a 1 to a 0 or a 0 to a 1. They call it a bit flip, and it can corrupt your data or crash your whole system. For decades, space agencies solved this by using these super expensive, super slow, basically bomb-proof processors. But StarCloud? They wanted to use a top-of-the-line, off-the-shelf NVIDIA chip, way more powerful, but also way more sensitive. So they had to find a completely new solution.
And this is just so clever. Look at their 3-part solution. For the radiation problem, a hardware issue, they used software. They used error-correcting memory and basically had the chip do its homework twice to check for mistakes. Then there's cooling. A vacuum is a great insulator, which is terrible when you need to get rid of heat. So they engineered this incredible system of deployable radiators. And finally, the sheer violence of a rocket launch, they just tested the heck out of it with brutal vibration tests and careful hand assembly. And guess what? It worked. They actually did it. They trained an AI model on Shakespeare in space.
So StarCloud 1 was a massive success, undeniable proof of concept. But, okay, it's one thing to launch a single satellite. It's another thing entirely to build a 4 by 4 kilometer data center in orbit. And that's where the big, crucial question comes in. Is this whole thing just a cool science project, or does it actually make any sense? Let's be real for a second and look at the powerful case against StarCloud.
All right, time for a reality check, because honestly, there are some very serious, very smart people who think this entire venture is just fundamentally flawed.
This is really the heart of the skeptical argument. For every promise StarCloud makes about space, there's a pretty big yeah, but. So, free solar energy. Yeah, but have you seen the price tag on a rocket launch? It's still way cheaper to build a power plant down Earth. Endless space for cooling. Well, a vacuum is an insulator. It holds heat in. It's like trying to cool your laptop inside a thermos. Unlimited physical space. Not really. The best orbits, the ones you'd want to use, are already getting dangerously crowded. It's like a cosmic traffic jam up there. When you run the numbers, the whole thing just feels shaky.
And yet, despite all these seemingly killer arguments, StarCloud isn't some lone wolf. We're talking about Google, Amazon, SpaceX. The biggest players in the game are all exploring this exact same idea. So that begs the question, right? What do they see that the skeptics are missing? Why are they all racing to do this supposedly bad idea?
And that question leads us to the big twist in this story, the thing that changes how you look at this entire project.
It turns out the goal was never to replace data centers on Earth. All that talk about competing with facilities in Greenland or wherever, that's a total red herring. It's a distraction from the real mission. The real play here, it's to build a cloud for space. They're not trying to replace Amazon Web Services on Earth. They're trying to become Amazon Web Services for the entire growing space economy. And you know what? This is becoming a genuine necessity. Think about it. You don't lug a server around in your backpack to use ChatGPT on your phone, right? You access the cloud. Well, satellites are generating insane amounts of data, terabytes of it. Sending all that back down to Earth is slow and inefficient. But if you can process it right there in orbit, what we call edge computing, you can turn hours of delay into minutes of action. Imagine spotting a wildfire from space and alerting firefighters in minutes instead of half a day later. That's the power we're talking about. It's on-demand computing power for telescopes, for the ISS, for this whole interconnected network they're building.
So when you put it all together, what does this future actually look like? This isn't just a replacement for something we already have. This is a whole new layer of infrastructure for humanity.
And their roadmap is, well, it's just wildly ambitious. They went from their proof of concept last year to planning a satellite 10 times more powerful for next year. And they're still shooting for that massive 5-gigawatt data center by 2035. They don't see this as just another step. They're calling it an iPhone moment for the space industry, a piece of fundamental tech that's going to unleash a wave of innovation we can't even imagine yet.
So I want to leave you with this final thought. Maybe the idea of uploading all of our data, our photos, our entire digital lives to a server in space, maybe that's still a bit far-fetched. For now. But building the cloud for space, that's not science fiction anymore. That's happening. And it really makes you wonder, in 10 or 20 years when you look up at the night sky, will you just be pointing out the moon and the stars? Or will you also be pointing to a giant, glittering square in the darkness and saying, that's where the new frontier is happening?